I'm Belhadj, and this is my Lab 4 report on oscillations. The purpose of this lab is to examine the motion of a spring mass system using tracker, then compare the predicted motion and the observed motion of the mass and plot the energy changes that you compute in the model. A brief preview of the results is that the position for the predicted and observed models were similar and the total energy of the system is 0. Newton's second law states that the force of an object is equal to its mass times its acceleration. In other words, the force is equal to the rate of change of momentum. Newton's law of universal gravitation states that every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Hooke's law states that the force needed to extend or compress a string by some distance scales linearly with respect to that distance. The energy principle relates to the change in the total energy of the system to the total work done on the system by the surroundings, and the exchange in energy between system and surroundings due to a difference in temperature. Work is the dot product of force and displacement. Kinetic energy is the energy associated with motion. Gravitational potential energy is the potential energy associated with gravitational interactions within the system. Spring potential energy is the potential energy that exists due to the stretch or compression of a string within the system. Here is the tracker video. And I've pasted these X and Y data values into Excel to save them in a CSV file. And here's the X graph and the Y graph. Let's take a look at the code. Here I've inputted the mass and I've inputted the initial conditions for the position and the velocity to make it more accurate. And I've changed the spring constant, the relaxed length of spring, and I've changed the time frame, and I've inputted the equation for the gravitational force, the spring force, and the net force. And then I've plugged in the velocity update equation and the position update equation. And then I've inputted these equations to update the spring and these equations to calculate the different energy changes, whether it's kinetic, potential energy. As shown, the total energy of the system is 0 when adding the spring, gravitational, and kinetic energies together. This shows that no work was done on our system by the surroundings. The position for the predicted and observed models are similar. They show the consistent oscillations of the mass with slight deviations. When it comes to the possible errors, it may be because of the center of mass. It wasn't consistent at each interval. Furthermore, it could be because there were other forces and energies not taken into account, like the drag force or rotational kinetic energy. For your model system, is the energy principle satisfied? By the energy principle, the work done is equal to the change in energy of the total system. If no work is done, the change in total energy should be equal to 0, which is what we see here. This means the energy principle was satisfied. Let's discuss the estimates of oscillation periods. Although the predicted and observed models were similar, there was a little discrepancy. This can be solved by calculating the oscillation periods in the x direction and from there derive the spring constant. These calculations of 1.638 seconds and 1.5004 seconds do differ, but what we can do is take the average and plug that into the computational model.